So again, just to show you the DNA, you got to remember there's three parts to it, okay? The main part is the nucleic acid, which is held by the 5-carbon sugar, which is in a 5-membered ring, but one of those is an oxygen, so there's a carbon arm up here, CH2, holding on to the oxygen of a phosphate. Learn your phosphates because there's 4 oxygens and they're all different ionic characteristics here, electronic characteristics. One is charged, so it's got a paired electron, but nothing bound to it, so it's a negative overall. You get oxygen to carbon in the ring, and then you get a double bound oxygen to the phosphorus. So some call them phosphates when there's got the 4 oxygens. When they're going through their reactions, they're technically phosphoryls because it's the 3rd oxygen that binds, and it gets really chemical then. So this is the end of this plate that was the DNA. Keep the soundtrack going, so I'm not going to stop it. Whiteboard cleaner. All right, so what I got to talk about is, see our periodic table here, the carbon, nitrogen, oxygens. These were the big guys. Well, we got to start with what an atom looks like. Remember we had our proton, neutrons. So in the middle of a nucleus, protons are plus. Draw that bigger, okay, since we're doing the middle of an atom. Plus charge on protons. The number of protons dictates what element it is, okay? So remember, 1 proton by itself was a hydrogen. 1 proton with a neutron, it's still hydrogen. They'll call it heavy hydrogen. 2 neutrons, 1 proton, still hydrogen. They'll call it tritium because it's got a weight mass of 3. But now, another proton. This is that alpha particle. Remember what we were talking about? So the alpha particle equals helium. And helium is one of the first noble gas, they call it, right? Well, it won't react with anything because there's a thing called the electron shell. So the electron shell, the first shell, is only going to have 2 electrons around it. So you got to picture this as kind of being a cloud, and what it's really based on is the distance from the nucleus to where the majority of the density of the electrons are. So it forms this electron density shell at a certain distance from the nucleus, right? Well, now for lithium, see, the next element is going to have to be in what's called the next shell, which is going to be further from the nucleus. So this electron being further away magnetically, right? If it's electron negative, the positive on the protons would hold these together. If it's further away, it's going to be easier to pull away. So what we find is that 8 of them forms the next shell. 1, 2, 3, 4, 5, 6, 7, 8 electrons. That forms neon. So what we notice now is neon is going to have 10 protons. But when it comes to the electrons, we got to remember 2 of those electrons are on the inside shell, so it's only the 8. Once that shell's filled, it goes out to the next shell. So neon has a total of 10. This is why everybody gets confused. 2 are on the inside. It's going to have 10 pluses in here, and it can have 10 or 12 neutrons, depending. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 protons, and either 10 or 12 neutrons. So see, it's little lowercase no, N superscript up O for the neutron, P upper script plus for the proton, E with just a little negative for the electron. So there's only 3 particles. And what's confusing is the electron is tiny. These things are like 1,832 to 1,900 times as big as the electron. So when you're studying this, you read in the book, the first thing they talk about are the protons, neutrons. Well, it's the electrons is what chemistry is, okay? The electrons. Nuclear forces in stars were how these elements are made. Those are the nuclei. But for chemistry, it's the electrons. So this is what I need you to know. The number of protons for the stable atom to be balanced out is why the elements are listed the way they are in the periodic table. So when you see carbon, even though it's got a 6 protons, 6 electrons, 2 are on the inside. So only 4 are involved in the bonding. That's the tetrahedral. Tetra's 4. So the nucleus is the protons and the neutrons. The electrons filling shells out here, energy shells. 2 in the first, 8 in the next. Then there's another one with 8. And that's why you can look at the noble gases on the periodic table way over there. Neon, argon. Argon has a shell with 8, 8, and 2. So it's really simple when you get the hang of this because all the elements want to have a stable configuration of electrons. So fluorine only has 7 in this outer one. It wants 1 more. That's why you'll either have a fluoride, which is F minus, because that extra electron that it takes gives it its outer shell of 8. Or you'll have F2 because each F will do a covalent bond and share those. So I'll go over this some more, but just get this part down first. I've seen these books because they make questions and they'll ask the same question in a different way, and I've argued with parents how to go about teaching it. Okay, so the first thing we're going to start with is hydrogen, and what the hydrogen exists as is H2. Okay. so light, hydrogen H2 gas, what it's going to be is going to be a proton. We got two of them. What we're going to find is the electrons are how they bond. Remember, each of these has one electron. So what we find is the majority of the energy is between the protons. So the whole atom itself overall is neutral. So it would have this kind of shape to it, and that's why they'll draw it as, I always draw hydrogen H with red. You draw this as H. And I don't know if they stress this enough, but whenever you see a line, a chemical molecule, that means that's a pair of electrons. And that's how these bond together. So the distance between these two protons is called the atomic radii is half, so both of them would be the atomic diameter, I guess, from center to center. So picture it. Whenever you see a line, that's two electrons. That's the pair. That's what holds them together. So for hydrogen gas, H2, these just happen to get to where they're like magnets. They're happy. The electron repulses the positives, and the positives push the electrons together, and there's a happy little H2 gas. Okay? So out in space, remember, we were saying the stars are going to make carbon. So the way you would picture a carbon, carbon 12, remember? 6 protons, 6 neutrons, that gives it the mass of 12. That's the nucleus. Okay. Electron in the first shell. The next shell out further away to give 6 going to have 4 of its own, so 4 other ones are going to come and bond. So let's take hydrogen, for example. Hydrogen's a proton. And each of those protons has an electron. So now you got a bond to hold that proton a certain distance out there. So see, now you've got 2, 4, 6, 8 in that outer shell. So what this makes is carbon, 4 H's, CH4. That's a methane molecule. So what you need to know is it's got a carbon with a mass of 12, 2 electrons in the inner shell, 4 in the outer shell. The hydrogens brings 4 more. So now you've got the 8. This is a stable methane. So you'll find methane one of the first molecules. Molecules are when atoms come and combine. So a neon atom or a helium atom, you don't call those molecules. Hydrogen, this is one where the people that don't know what they're talking about start calling them molecules. Well, if you call it hydrogen, they usually mean H2, but you got to be specific because a hydrogen is just one. And the teachers do it, even I do it sometimes when I'm not paying attention or I get really tired. So here is your methane. You can learn this distinction here between the carbon and nitrogen, you'll have it down. So nitrogen is usually a 14 that you'll find. What that is 7 neutrons,